All right, welcome back to Melange for React Devs. In this video, we're going to cover Chapter 3 on our Celsius converter. The summary of our chapter is taking a single input that converts from Celsius to Fahrenheit. And the topics we're going to cover is the JS type object, string concatenation, exception handling, ternary expressions, if-else expressions, labeled arguments, partial application, and JS quoted string literals. Celsius converter. Our second widget will be one that takes a temperature value in Celsius and converts it to Fahrenheit. Create a new file called celsiusconverter.re. So let's grab this and we're gonna go make that file. In fact, let's open these side by side. And we'll come over here and we'll make a new file and we'll say that's going to be celsiusconverter.re, and we'll save that. And let's paste the contents of that in there. celsiusconverter.re. Perfect. And now let's go ahead and try to build. npm run build. That looks happy. And there we go. Okay, so this should be typed as a float. Perfect. The js.t object. Inside the inputs on change handler, we get the event target using react event.form.target, which has the type of taking a react event.form.t to this like spreaded object thing. So what's this? It's shorthand for the js.t object type, which consists of two parts. js.t refers to JavaScript objects in Melange. The other part refers to polymorphic objects, which can contain any fields or methods. Once we have a js.t object, we can use the hashtag operator to access its fields. But beware, because the compiler knows nothing about the types of those fields. For example, we could write react event form.target event value plus 1, treating it as if it were an integer, and the compiler would not complain. Instead of trusting ourselves to always use form.target correctly, it's a good idea to wrap functions that return polymorphic objects into type annotated helper functions. For example, let get value from event takes an event that returns a string. And then we called the same thing there and we pass it in. So let's make that change to our code. So let's come up here and we will make this function, and it'll be let get value from event equals event, and we'll return a string. And then in here we'll say react.event.form.target, pass in the event, and then we'll get out the value. And we can take that and we will, let's see here, let's make that a little bit bigger. We'll pass that right here. Oh, too much. Get value from event. And this should come back as a string. Perfect. The colon string after the argument list tells the compiler that this function must return a string. Using the getValue from event function ensures that the value field can't be used as anything other than a string. Another thing to note about onChange is that after the event argument, the body of the callback function is surrounded by braces. OCaml functions are like JavaScript's arrow functions. If they contain more than one line, they need to be enclosed in braces. Apply pipe blast. Let's change the render logic to update the Fahrenheit display based on the value of Celsius. So we'll copy this. So let's go in here and we're going to clear this and we'll say Celsius, and we'll pipe that into float of string, and we'll pipe that into convert, and then we'll say convert that to a string, and then we'll pipe that into react.string, which converts it to a React element. Cool, so that looks good there. The pipe blast operator is very handy here, allowing us to convert a string to float, then convert that float to another float, convert back to a string, and finally convert the string to a React element all in one line. Next up is string concatenation. We should probably put the Fahrenheit symbol after the Fahrenheit value so it's clear to the user what unit of measurement they're seeing. We can do so using the string concatenation operator. So we are going to take this, it looks like, and we'll come here and we're going to wrap this in parens, and then we're going to jump back over here and we're going to add, use our string templates, and we'll put, well, I'm gonna have to copy this. So let's grab that and we'll paste that in there. And that looks right. Cool. Catch exception with switch. However, there's a bug in this code. It will crash if you enter anything into the input that can't be converted to a float. We can remedy this by catching the exception using a switch expression. So we're going to add a block and we're going to switch on the value. Oh, because we could incorrectly convert. Okay, so let's come in here and we'll switch on this and we'll jump to the end of this line, throw a block there, and we'll match on our exception, and we'll say any exception. We'll just return error, and then in here we'll match on our actual string we parsed. If I could type. And we'll do plus plus our string literal. In fact, we can just grab this from there, come to the end of the line, paste that in. And that needs to be an arrow. There we go. That formats, everything type checks. The exception branch will execute if there is any exception. The underscore is a wildcard, meaning it will match any exception. If we wanted to be specific about which exception we want to catch, we could instead write catch failure underscore error. I am going to leave this as is for now, so we catch all errors, but you can effectively pattern match on the types of exceptions that could be raised. Ternary expressions. Right now it correctly renders error when you enter an invalid value, but it also renders error if the input is blank. It might be a bit more user-friendly to instead show question mark Fahrenheit like before. We can do that by wrapping the switch expression in a ternary. Let's actually get this running before we write any more code and take a look at what we have so far in the browser. So let's jump back over to our index, and rather than rendering our counter component, we want to render our Celsius converter. So we'll save that. We'll open up our console and we'll say npm run watch, and that will start Dune in watch mode, and then we'll run npm. Oops, let's get our shell. Is this gonna, yep, that should be good. So it looks like we can use serve. So let's say npm run serve, and that should open Vite for us. Yep, there we go. Perfect. And we have our working converter, but we should get errors if we, yep. So the problem we're gonna fix now is that we have an error by default. We should only get errors when we enter invalid numeric values. So let's go ahead and go back to our file. And in our Celsius converter, we want to come down, and in our block where we render the string, we'll say tab over Celsius equals an empty string. If it does, we will return a string that says question mark Fahrenheit. We'll drop that in there. And otherwise, we'll render our block. So let's see what that change does. So now we have the question mark Fahrenheit, and if we come in and enter a number, it should work. But if we enter text, perfect. If-else expressions. The ternary expression condition A or B works the same as in JavaScript, but in OCaml, it's also a shorthand for an if-else expression. If condition A, else B. So we could rewrite it as if Celsius equals empty string, return this. Otherwise, return the evaluation of this switch expression. Unlike in JavaScript, the if-else construct is an expression and always yields a value. Both branches must return a value of the same type or you'll get a compilation error. In practice, if-else expressions aren't very common in OCaml code because in simple cases you can use ternary, and in more complex cases you can use pattern matching with the switch. But it's a nice familiar fallback you can rely on when you haven't quite gotten used to OCaml syntax yet. Labeled arguments. If we enter a value with a lot of decimals in it, e.g. this number, we'll get a Fahrenheit value with a lot of decimals in it as well. We can limit the number of decimals in the converted value using js.float.toFixed. So in here, we're going to add our branch where we get our Fahrenheit string, and we're going to js.float.toFixed. So let's do that. Let's go ahead and bump this down, and this will become js.float.toFixed, and we'll pass in Fahrenheit. And we'll give it a labeled argument, digits equals 2. Up here, we removed the last part where we convert to a string, so let's remove that. And we'll cut that out, and that should fix our type error, and there we go. And let's go check our code over here. Yeah, now we're forced to only have precision of 2, or 2 decimal places. js.float.toFixed is a function that has one positional argument and one labeled argument. In this case, the labeled argument is named digits, and it's receiving a value of 2. It's not possible to pass in the value of a labeled argument without using the tilde label equals value syntax. We'll see more of labeled arguments in the following chapters after we introduce props. Partial application. You might have noticed the function chain feeding the switch expression got a bit shorter from this to this. This happened because string of float, which takes a single argument, was replaced by js.float.toFixed, which takes 2 arguments. And functions chained using the pipe can only take a single argument. But this one argument restriction actually doesn't prevent us from putting js.float.toFixed in the chain. We can take advantage of OCaml's partial application feature to create a one argument function by writing js.float.toFixed, passing in the labeled argument. Then our switch expression becomes like this. So we can grab this and we can say we're going to pipe that to js.float.toFixed, and we'll pass in our labeled argument of digits, and that'll equal 2. And then down here, we'll take Fahrenheit and we will add it to the symbol. And that should work. Let's go take a look. Perfect. Quoted string literals. Try changing this to this. All right, so let's try that. Let's copy this. And we'll come in here and we'll replace you with that. And let's go take a look. We got, as it calls out, a bunch of gibberish. We can't rely on normal OCaml strings to deal with Unicode correctly, so any string that contains non-ASCII text must be delimited using the JS quoted string literal syntax and not simple strings. This kind of string constant is called a quoted string literal and is specific to Melange, meaning is not available in native OCaml. Nice, we have a working component now, but catching exceptions isn't the OCaml way. In the next chapter, you'll see how to rewrite the logic using options. As an overview, we covered the js.t object types and how it can have fields of any name and type. We learned how to access those fields and how to use type annotations to make those interactions safer. We learned how to concatenate strings, how to use if and switch expressions and ternaries along with pattern matching. We learned that if-else expressions are, well, they're actually expressions that return values. Besides positional arguments, OCaml functions can also have labeled arguments, and if a function takes 2 arguments, we can supply one of them and get a function back that only takes 1 argument. This is called partial application. And we also learned about quoted string literal syntax. So for the first exercise, it's possible to rewrite the onChange callback to be a one-liner. So let's go ahead and change that. And we'll be in here, and this is going to be get value from event, delete that. This compiles now, but it contains a hidden bug. Do you know what silent error might occur? I actually don't know what the problem is here. Let's check the hint. The get value from event function is no longer being invoked in the same scope as before. It's being invoked inside of the callback here. So is it possible? I think this is an event persist problem. Rewriting the onChange handler to use a single expression creates a potential problem with stale values coming from the event object. Inside of onChange, we can expect the function getValueFromEvent to return the latest value of the input. However, we are now calling getValueFromEvent from a different function. The callback we passed is setCelsius. By the time that setCelsius callback is invoked, the event object might have been recycled and no longer have the same value as when onChange was initially invoked. For more details about this, see using event values with useState in the Reason React docs. This is often why you'll see like event.persist in React code. Okay, exercise number 2. It's possible to use partial application with most functions in OCaml, even operators. Take a look at the following program. Let add 5 equals plus 5. js.log add 5 2, js.log 7, 10. What do you think it outputs? So this is a good example of partial application. In OCaml, our operators are really just functions. So this is saying take the plus function, apply 5 to it. And since OCaml has partial application, this is going to return another function that accepts 1 argument and will perform the rest of the math. So if we paste this in, yep, there we go, 7, 12, and 15. Exactly what we would expect. So you can see kind of what this compiles to, right? So add 5, this function is a param that takes 5 and then adds a param or 0. Or I guess not or 0, but finally, the last exercise, use the pipe operator. Use the pipe last operator in partial application to write a function that takes an integer x, subtracts x from 10, and converts that result to binary. Okay. I believe, what would we call this? It takes let's just say my function, and that's going to take a argument, we're in reason, is going to take a integer x, just say this is an int. Oh, it only takes 1. So we can do that, and we'll come in here, give ourselves a function body, and let's give ourselves some room here, and we'll say 10 minus x, and then converts that result to binary. I believe we can use, I actually don't know how to convert that to, I think we can use toString, and then toString has a, into string has a js.int.toString, and it's going to be, I don't think it's binary. Let's go look this up on Mozilla. Mozilla toString. In fact, we can go, this is probably the one we want. We want it to be, 2. We want it to be in base 2. This expression has type string and is not a function that can be applied. Why not? So what is the radix argument here? An integer. Well, let's see what the function signature of this is. See if we can figure this out. I can't get type definition, so let's just go ahead and look at the solution. And we'll open up a code playground. And here's how they solve that. Oh, it's a labeled argument. That's why. Nice. Cool. Well, that is going to conclude the chapter on our Celsius converter.